Sir.
Good evening, sir.
Good evening, sir.
Good evening. Good evening, everyone. Just
Good
1
evening,
minute,
sir.
please. Yes. Okay, so Rudra has some doubt. Okay, Rudra, you can ask those doubts. We can start with your doubts.
Sir,
And
I was doing my physics homework, sir. They gave 5 questions to solve, sir. I got the answers, but I'm not able to understand how to solve the by method, sir. Can you solve, sir? I'll send the questions in
yeah,
chat.
yeah, please share it in the chat. Share your doubt in the chat. And here everyone will try to solve that. A force acts for 0.2 seconds on a body of mass 2.5 kilogram initially at rest. The force then ceases. Okay, just 1 minute.
Sir, this was given by Rajnan, sir.
Just 1 minute. Okay, so this is your question. Oh, you have sent a number of calls. We start with the first one. Let's see. Okay, just 1 minute. Just give me 1 minute. So your first question is here. A force act for 0.2 second on a body of mass 2.5 kilogram initially at rest. The force then ceases to act and the body move through 4 meter in the next 1 second. Calculate the magnitude of the force. All right.
Sir, are you presenting?
Okay, I think I'm not. Just let me present it. Okay, a force act for 0.2 second. Now let's assume the situation. You have here some body and on this a force F is acting for 0.2 seconds. So everyone, this doubt is not for just one person. Everyone should look up at it. Okay. So this is a force F is acting on it. The time for which it acts is 0.2 seconds. All right. Finally, the object comes here. It attains some velocity. its initial velocity was at rest. After the application of the force, the object attains some velocity, and after attaining the velocity, it moves through a distance of 4 meters. Okay, in 1 second. So it is moving a distance of 4 meters, and the time it takes is 1 second. All right. So Pranav, Pranav, Pranav. No, Pranav, you are not audible. Unmute yourself.
Sir, am I audible now?
Yeah, now you are audible. Yeah, you are audible now. So Pranav, can you tell what is the velocity attained by it?
Sir, it's 4 meters per second.
Hmm?
4 meters per second, sir.
Yeah, here velocity attained is it is 4 meter per second.
Sir, 4,
Sorry, I'm
4, sir.
yeah. How I know that the velocity attained is 4 meter per second?
Because velocity is displacement by time, sir. Here displacement is 4 meters and time is 1 second. So it's 4 meters per second.
And also there is no force. Here during this situation, the force is 0.
Yes, sir.
Okay. So I can say that the velocity attained by it is 4 meter per second. So the initial velocity is 0. Final velocity is 4. Time I am given. Can I find the acceleration here?
Yes, sir.
So what will be the acceleration?
Sir, it's 4 minus 0.2 by time, sir.
Hmm?
4,
Sir,
4 minus 0.2 by 1, sir. 1 second.
No, 4 minus 0 divided by 0.2.
0.2. Sorry.
Okay. So this is 40 over 2, which is 20 meter per second square. Got it, Rudra?
Yes, sir.
Okay. Then can you tell the amount of force?
Sir, force is mass into acceleration, sir.
Okay.
Sir, they already gave mass which is 2.5 kg.
Mhm.
Sir,
Into 20 we should do, sir.
Yeah, the answer is 50 Newton.
sir, in the case of acceleration,
Okay, sir.
Hmm?
Thank
like it, sir, I have a doubt.
Yeah.
Sir, it's not 4 minus 0, sir. It's 4 minus 0.2. So we should 4 minus 2
No,
by
no.
10 now.
No, the formula of acceleration is
Change in
final
velocity by time.
velocity minus the initial velocity divided by time. This is the formula of acceleration. Final velocity minus initial velocity over time. So the final velocity here is 4 meter per second. Initial velocity is 0. Time is 0.2. So we obtain the acceleration as 20 meter per second square.
Okay.
So it's the correct answer. Now just look up at the second question. The velocity of 108 km
Sir,
per
can you
hour.
explain the diagram you have drawn, right? I'll join later.
So this diagram is for question number 1. Just go through this question number 1. This diagram
Yes,
is for
sir.
question 1. Okay. So according to question number 1, a force acts for 0.2 second on a body of mass 2.5 kilogram initially at rest. The force then ceases to act and the body moves through 4 meter in the next 1 second. So here the time is 0.2 second, mass is 2.5 kilogram, initial velocity is 0. So I have made here initial velocity 0. The force is acting on it. Okay. So force acts for time 0.2 second, and after that the force stops to act. Okay. So when the force stops to act, then after that it says, suppose when the force starts to act, then there is no acceleration. So it continues with a constant velocity v meter per second. All right. But it's given that it is traveling 4 meter in next 1 second. So I can find the final velocity to be 4 meter divided by 1 second, which will be 4 meter per second. Got it? Now I obtained the
Okay.
final velocity. I know the initial velocity and I know the time for which the force acted. So I can find the acceleration, which is v minus u over t. So acceleration is found as v minus u over t. So it is v minus u over t. So you can find it. We found it this. So shall I move to the next question now?
Yes, sir.
Okay, the second question, I think it's incomplete. Let me check the second question once more. So I think it's in the chat. Hmm. Just check your second question is incomplete, Rudra.
Sir, 1 second, sir. Checking, sir.
Just check. It's given the velocity of 108 km per hour and it takes 5 seconds to stop it after the brakes are applied. A little bit of grammatical mistake only, I think. Just check.
Sir, 2 minutes, sir. Sending again.
Okay, I think it's here. It should be like this. Calculate the force exerted by the brakes on the motorcycle. If its mass along with the rider is
Not that, sir.
250 kilogram, the velocity of 100 and moving with velocity of 108 kilometer per hour. And it takes 5 seconds to stop it after the brakes are applied. I think the
Sir,
question is like
not
this.
that, sir.
It is not visible, sir.
I'll
Your
send
screen.
it, sir. 2 minutes, sir.
Yeah?
Your screen is not visible, sir. Like main screen.
Yeah, that screen is not visible, but I'm just looking at the question. Just I'm resharing it. Can you see the now? Can you see the screen?
Yes, sir. Yes, sir. Like I, like I don't have the problem, sir. I didn't see this board, sir.
Okay, so this question is actually like this. Just I'm making a little bit of change in this question. It's like this.
Sir, I sent the correct question, sir.
Okay, I got it. I got it in the WhatsApp group. No, I didn't get on the WhatsApp.
Sir, I sent it in.
Chat box.
I sent it in chat box, sir.
Okay. This one. Yeah, so that's what I said.
Sir, I did not understand what you said, sir. It was given from resonance.
Hmm. Okay. ఇదే దొరుకుతుందా అదే దొరుకుతాయి కావాలి ఇట్లా so see here, a motorcycle is moving with a velocity of 108 km per hour and it takes 5 seconds to stop it after the brakes are applied. Calculate the force exerted by the brakes on the motorcycle if its mass along with the rider is 250 kilogram. Okay. So let's see. Let's take your motorcycle here on the road. And we have our cycle. So I can't draw the cycle perfectly, but still, okay. So it's somehow like this. So your motorcycle here is moving with an initial velocity of 108 km per hour, and when the brakes are applied, it takes 5 seconds to stop it. So the time taken is 5 seconds, and if it stops, suppose it stops over here, so what should be the final velocity?
Zero,
Since it is stopped, yeah, what should be the final velocity?
it should be zero, sir. Zero,
Zero, yeah.
zero
Since it is
kilometer.
stopping and any stationary object has a zero velocity, so the final velocity of the motorcycle is zero. Now, can you find the acceleration, Rudra?
Yes,
Rudra,
sir.
can you tell? Okay, so what
Sir,
will be the acceleration?
Sir,
1
it
second,
seems
sir.
like a retardation, sir. It's a retardation problem
Yeah, there is a retardation.
because it is decrease in acceleration, sir.
It is
Decrease in acceleration.
decrease in acceleration. Yeah, it's decrease in velocity, so it's an acceleration.
Sir, I also did not understand how to calculate how much time it takes to stop, sir. Like in each second, how many?
No, it is taking 5 seconds to stop.
Yes, sir.
Okay, so we will use the formula of acceleration, which is A equals to V minus U over T.
Sir, what is U again?
U is initial velocity, V is the final velocity.
Okay, sir. So initial velocity is 108
Yeah,
kilometers per hour.
yeah, but we need to convert it to SI system of unit first.
Yes,
Okay.
sir.
Initial velocity being 108 km per hour will be converted to SI system. So this would be equal to 108 multiply 5 over 18. Okay.
Into 5 by 18, why, sir?
30
We
meters
are,
per second, sir.
that is the method of converting kilometer per hour to meter per second. That's a shortcut method. A long method is like you have to do 108 multiply 1000 and divide by 3600.
Okay, sir.
Sir, the
Why we have
acceleration,
to do
I
like,
got the answer, sir.
okay.
The acceleration is minus 6 meters per second, sir. Retardation.
Okay, just 1 minute. So this you cancel these zeros. You get here 2, 5 times 10, 2, 18 times 36. So it's 5 over 18. You can cancel this 18 and 108. It's 6. So 6 times 5 is 30. So initial velocity is 30 meter per second.
Okay,
Final
sir.
velocity is 0. So you put the values here, final velocity to be 0. Initial velocity is 30 divided by time, which is 5.
Okay,
Right?
sir.
So this would be negative 30 over 5, which is negative 6 meter per second square.
Got the time.
Okay. This is negative 6 meter per second square.
Okay, sir. It makes sense. Sir.
So I got the acceleration. Now what will be the force then? Everyone tell me the force. What will be the force?
Sir, mass by
Mass into
acceleration.
acceleration.
Okay. Now, since there are a number of students who might not be aware about acceleration and other things, is there anyone who is not aware of the acceleration?
Sir, now it
Sir,
makes sense, sir.
Sir, I don't,
Yeah.
Sir,
I don't know,
the
sir, what is the
formula
meaning
for
of acceleration.
the
Sir, I
formula
don't
for
clearly.
The formula for?
the formula for force is mass into acceleration.
Yeah, the formula for force is mass into acceleration. And what is acceleration?
Sir, I'm Rudra, sir, it's minus 6 meter per second square, sir.
Yeah.
Sir, but if minus 6 meter per second square.
Yeah.
Sir, but if we multiply it with the mass, sir, we'll get into negative Newton, sir.
Yeah. Yeah. The force will be negative. So
Sir,
brakes are up.
but they also give answer key, sir, in that it's showing the positive 1500 Newton it's showing, sir, not negative.
Sir, minus 1500 Newton, sir. But the force should be positive, no, sir?
Yes, sir. It
No,
can't
it's,
be negative, sir.
who said force can't be negative? Hmm? Yeah, remove this. Who did this? Just remove this. Remove this. Who made a scratch? Who is this making the scratches? Please remove this. Yeah, better clear this. Whoever is doing this, clear this. What you got? Or just 1 minute. Let me see if I can find out who did this. Mm.
Sir, I can like you can remove the screen and you can again share it.
Yeah,
Sir, I guess you can just
you
unshare your
can.
screen and share again. I don't know.
Okay. So, anyways, I don't think that anyone is able. I shall reshare. Then I think it might be okay. Mm. Okay. Am I sharing the screen?
Yes, sir. It's all gone.
Now it's
Okay. Anyways, now it's gone. We can continue here. So,
Sir, force is minus 1500 newtons.
yeah, force can be negative. It's not that force can't be negative. Okay. So
Sir,
force
but in
can
the
be.
objects they gave only 1500 newtons, 700 newton, 1000 newton, and 1200 newtons.
Okay. So you take the positive value only, which is the same as it.
Okay, sir.
Okay.
Typically,
Choosing.
what is negative force, sir?
Yeah.
Typically, what is negative force?
What is
Negative force.
negative force? A force which is acting in a direction opposite to the displacement is a negative force.
Okay, sir.
Friction, sir.
See, and another thing is that every time we take the choosing of the coordinate is our will. We can choose the coordinate as per our wish. Okay. So if I choose like the direction of generally we choose the direction of displacement to be the positive direction. So here in this case the force will turn out to be negative. So there is nothing that force can't be negative. Force can be negative also. An opposing force is a negative force. All right. Okay. Now the next question is here. Next question is the third one. The net force acting on a body of mass 1 kilogram moving with a uniform velocity of 5 meter per second is. So the answer for this is just in the concept. Its answer is 0. Okay. It's 0. How can I say that the force is 0 here?
With a uniform velocity.
Yeah. with uniform velocity, so acceleration is 0. All right, it's moving with a uniform velocity.
Sir, so the answer will be 0 newtons.
Yeah, the answer will be 0 Newton since acceleration is 0.
Okay.
All right. So got the answer, doubts, all your doubts cleared, Rudra?
Sir, more 2 questions are there, sir.
Okay, okay, you sent question 5. Okay, in a hydraulic press. All right, I take these 2 questions also. Okay. So in a hydraulic press, of course, in a hydraulic press, a force of 30 Newton is exerted on a small piston of area 0.15 meter square. Force exerted by a large piston on load if it has an area of 0.75. So again, this question is incorrect. It's a little bit of.
Sir,
Okay.
can you give me your number, sir? I'll send the photo.
Yeah, send the photo. Yes, send the photo.
Yes, sir.
You can send the photo on my WhatsApp number also. Just okay, share it on my number. That would be easy. You can share here. Okay. Okay, so this is question number 10 and 11. All right.
Yes,
Yeah,
sir.
so you missed out the commas and all, so that's why it came out to be meaningless, right? Just I'm getting the question again. All right. Yes. Okay, is there anyone in the class who is not getting anything? Who is like feeling like something he is not getting? Anyone? Okay, so this is the question. See, in a hydraulic press, a force of 30 Newton is exerted on a small piston of area 0.15 meters square. A force exerted by large piston on load, if it has an area of 0.75 meters square, will be. Okay, so the question is pretty simple here. See, it is on, the question is based on Pascal's law. Okay, so according to the Pascal's law, the pressure is transmitted undissipated through any fluid. Okay, so what are pistons? Let's see. Have you observed a syringe? Yes.
Yes, sir.
Okay, so in a syringe here, a syringe looks something like this, and
Yes.
here you have something to inject over here. Here you have a, so this portion is called as a piston. This one which we are pressing inside the cylinder, this is the piston. So this one we call as the piston. Got it? This is the piston, and this one is the cylinder. Your syringe portion is the cylinder. All right. So this question is actually based on the Pascal's law. According to the Pascal's law, whatever pressure you apply from here, the same pressure will be transmitted undissipated to the other portion here also. The pressure at this point and the pressure at this point would remain the same. Right? So pressure remains the same. So first of all, we find out the pressure in the first case. The pressure in the first case will be given as force over area. So force here is 30 Newton divided by area, which is 0.15. All right. So since the pressure should remain the same, now we have to find out the force. The area is given as 0.75. All right. So 30 over 0.15 multiplied with 0.75 would be equal to the force. So 15 times 5, then it's 150 Newton as the answer. Yeah, so the answer is 150 Newton. Got it? Now, since you are small kids, so you can do this like this one also. So pressure we got here as force over area. So you can divide this 300 by 0.15. So 15 multiply 100, that would it would become. So the pressure would be 15, 2 times 30, 20, it becomes 2000. The pressure is 2000 Newton per meter square. Then the pressure remains the same. So you can find out 2000 to be equal to force per over area. Force divided by area, which is 0.75. Okay. So you
Sir,
multiply this.
300 by 15 into 100, why did you do? Into 100.
Yeah, thus I remove the decimal from here. Just
But
remove the
you
decimal.
already added 10 to the 30, right?
Oh, sorry, my bad. My bad. So I think here I shouldn't be adding 10 here. All right. So now it's okay. 15 2 times, so you get 200 here, not 2000. Okay, so this is 200 multiplied with 0.75 to be equal to the force. Okay, if you multiply this, you'll get answer as 150. So it's the same answer. Any other doubt? Okay, one more question is there. Question number 11. A car of weight 5000 Newton is being lifted by a large piston of area 4 meter per second square. Again, the same thing is applying over here also. The same thing. Just try everyone. Everyone try this question. It's exactly the same as question number 10. All of you try this question. All of you try out this question.
Sir, if we find the pressure, so the pressure should be same with the small and the large piston.
Yeah, the pressure should be the same. Since pressure is transmitted undissipated.
Sir,
Yes.
the car of weight 5,000, like the weight should be measured in kilograms or like.
See, here you should be converting this area into meter square and then it. Okay, got the answer. So now I'm solving this. Just see the solution. The initial pressure I can write as pressure P equals to force over area, which will be written as force is 5,000 divided by area, which is 4. So this is the initial pressure, should be equal to the pressure on the other piston also. So the force divided by area, which is 400 centimeters square. So the 400 centimeters square converted to meter square is 0.4, 0.04.
Yes, 0.04.
Okay. So you find out the force, which is 5,000 multiplied with 0.04 divided by 4. So 20 vanishes, it becomes 50 Newton is the answer A. Got it? Okay. All right, everyone. Thank you and
Bye.
happy learning.
Bye, sir.
Thank you, sir.
Bye, sir. Thank you, sir.